Hello students, welcome back to my channel. Those who are watching for the first time, please try to subscribe the channel so that whenever I upload a new video, you will be receiving the notification and also you will not miss any new topic. Okay, so today in this video, I am going to tell you the limitations of first law of thermodynamics. So far, we have covered the first law of thermodynamics and many other topics. So before going to second law of thermodynamics, we need to know the limitations of first law of thermodynamics and what is the exact need for the second law of thermodynamics. So as we all know students, first law of thermodynamics, what does it state? What is the statement of first law of thermodynamics? Do you remember? Yes. We know that energy can neither be created nor destroyed, and also one form of energy can be converted into another form of energy. Okay. So here I have mentioned the first point that the first law of thermodynamics states that various forms of energy can be converted into another. That is, when one form of energy disappears, another form of energy will appear. Okay, when one form of energy is used up, the another form of energy will be created in the of the same amount. Okay, students. But the law fails to explain in which direction the process takes place and also to what extent the conversion of one form of energy into another form of energy is possible. Okay, so it's failing to explain the direction in which the process takes place and also the extent of possibility of conversion of one form of energy into another form. And also third limitation, it does not or it is not able to predict whether a process can take place spontaneously or not. Okay, students. First law of thermodynamics, what does it state, ma? It states that one form of energy can be converted into another form. That means when one form of energy disappears, another form of energy will appear. It also fails to explain the direction in which the process takes place and also to what extent the conversion of one form of energy into another form is possible. And the third limitation, it is not able to predict whether a process can occur spontaneously or not. For example, I have given a few illustration examples here, students. First one, a gas can diffuse from a region of low pressure to high pressure or not. First law of thermodynamics does not indicate whether a gas can diffuse from a place of low pressure to a region of high pressure or not. Are you able to see, students? Right. Second example, whether water can flow on its own from lower part of a hill to higher part of a hill or not. That means generally water can flow on its own from higher portion of the hill to lower portion of the hill. But here we are quoting it as whether water can flow on its own from lower part of the hill to higher part of the hill or not. This statement, first law, is not able to explain. And also, we all know that heat can flow from a body of higher temperature to a body of low temperature. But here we are quoting that the first law is not able to explain whether heat can flow from a cold body to hot body or not. So, what all does the first law explains? It tells us that one form of energy can be converted into an equivalent amount of another form of energy. Okay? This much only it can explain. And also, it was observed that though various forms of energy can be completely converted into the other forms, heat energy cannot be completely converted into an equal amount of work done, students, without producing some change elsewhere. Okay, so we all understood that it just tells us that one form of energy can be converted into an equivalent form of another, equivalent amount of another form of energy, but it was observed that heat energy cannot be completely converted into an equal amount of work. So, therefore, there is now a need to mention about the direction in which the process takes place, which process conversion of one form of energy into another form of energy, and also to what extent actually the energy conversion takes place. So, these are the limitations, and this is the gap which has to be which leads to second law of thermodynamics, and all these will be explained by second law of thermodynamics. And also, students, there is one term which is called as spontaneous process, which we can find frequently, and also which is of basic importance in second law. Okay, so before going into second law of thermodynamics, we will learn about what this spontaneous process is. Okay, students, please stay tuned. So, students, put the side heading spontaneous process. What is a spontaneous process? Which is nothing but the process which takes place spontaneously, or which takes place on its own without any external help or assistance. Such process is called as spontaneous process, which can also be called as a natural process or an irreversible process. Okay, so generally all naturally occurring processes we can call them as spontaneous and irreversible processes. All spontaneous processes are irreversible, or all irreversible processes are spontaneous. All natural processes are spontaneous. Okay, so put the side heading spontaneous process and write the definition, students. A process which proceeds on its own without any external assistance is called as spontaneous or natural or irreversible process. Okay, now coming to the examples. So as I told you, water can flow down the hill spontaneously. For this, we need not give any external assistance or external help. Okay, suppose if you stand at the top of the hill and try to drop the water from the top of the hill, it will flow easily down the hill without any external help. This is one of the spontaneous processes. Next, second example, heat flows from a body of high temperature to a body of low temperature. This concept also we all know. It's the general flow of heat from a hot body to a cold body. Now, a gas expands from a region of high pressure to a region of low pressure spontaneously. Next example, when there are two solutions whose concentration is different, one is a concentrated solution, the other one is a dilute solution, and when these two solutions are separated by a semi-permeable membrane, generally we can find the diffusion of solute particles from a solution of higher concentration to solution of lower concentration. That's what I have mentioned here, students. Diffusion of a solute from a concentrated solution to a dilute solution when the two solutions are separated by a semi-permeable membrane. Okay, next, put the side heading non-spontaneous or unnatural process. This is exactly the opposite of spontaneous process. What is it, students? You can write on your own. Will you write? Yes. The process which is not able to take place, which is not able to proceed on its own and takes some external assistance, is called as non-spontaneous or unnatural process. What would be the example for a non-spontaneous process? Yes, water flowing from lower part of a hill to upper part of a hill. It will never happen until and unless some external help is given. Or a ball rolling from lower portion of a hill to upper portion of a hill. Okay students, you got the difference between spontaneous and non-spontaneous, right? A spontaneous means which can occur on its own. Non-spontaneous means which cannot take place on its own. So you can write the example for a non-spontaneous process. Water flowing from lower part of the hill to upper part of the hill. Have you written, students? Yes, or else you can take a screenshot of the video. You know students, when a spontaneous process takes place, generally there will be a decrease in internal energy or decrease in enthalpy. Okay, what happens when a spontaneous process takes place? It was observed that there will be a decrease in internal energy or a decrease in enthalpy. So internal energy, enthalpy, all these terms we have learned in the first part of thermodynamics. Okay, I think I need not repeat what internal energy is, what enthalpy is, right students? You can refer to the first part of thermodynamics. Now, what does this show? This shows that only exothermic reactions can take place spontaneously. What is an exothermic reaction, students? Where we observe that heat is released. Such reactions we call them as exothermic reactions. Okay, so we think that as there is decrease in internal energy or decrease in enthalpy, we think that a spontaneous process is nothing but an exothermic reaction. Okay, that is the meaning of this sentence. When a spontaneous process occurs, usually there will be decrease in internal energy or decrease in enthalpy, which shows that only exothermic reactions can take place spontaneously. But students, see, there is a but. Okay, melting of ice. You all know that what happens when ice melts or when water evaporates. These two are the examples of endothermic reactions. Okay, so you know what an endothermic reaction is. You know the difference between exothermic and endothermic reactions, release of heat and absorption of heat. Okay, so previously what did we think? We thought that as there is decrease in internal energy or decrease in enthalpy, only exothermic reactions can take place spontaneously. But look at the next example. Taking the examples melting of ice or evaporation of water, even though they are endothermic, they are the examples of endothermic reactions, they proceed spontaneously. Okay, they are spontaneous processes and they are not accompanied by either decrease of internal energy or decrease of enthalpy. Decrease in internal energy we denote it by delta E, and decrease in enthalpy we denote it by delta H. Okay, so what can we infer from this example? Melting of ice and evaporation of water, even though they are endothermic reactions, they are taking place spontaneously, and also we do not find any decrease in internal energy or decrease in enthalpy. So what can we infer? We can infer that other than delta E and delta H, other than decrease in internal energy and enthalpy, there is some other factor which is taking authority over this spontaneity of a chemical reaction, or which governs the spontaneity of a reaction. Okay, so what is that the other factor? Now, before telling you what the other factor which is governing the spontaneity other than internal energy and enthalpy, I want to tell you something. Take this melting of ice. So when it is in the form of ice, okay, that means it's completely in solid state. We all know that the molecules in a solid are arranged in a regular pattern and giving it a crystalline structure. Okay, we can find the molecules in an orderly pattern, right, students? So will the molecules be able to move freely in a solid? No, right? Little movement they have because they are tightly packed. So when ice melts, what happens? Ice melting means what? It is converting into liquid. We all know that the molecules of a liquid. Now the water molecules, they are now far away from one another, so they can move freely. And also, if we look at the pattern of the molecules, there will be a lot of disorder in the structure. And even if you take the evaporation of water, evaporation means what? Water converting into gaseous state. When you compare the physical state of molecules in a liquid and gas, in a gas they are more free to move when compared to liquid. That means there will be much disorder in the vapor state when compared to liquid state. Okay, now this disorder, okay, orderly structure converting into a disorderly structure. In order to explain this disorder, a new term is being introduced by second law of thermodynamics, which we call it as entropy, students. This is the other factor which is governing the spontaneity other than internal energy and enthalpy. Okay, so this is the point here, students. Please you can see I am showing here. You can write it down in your notebooks. I will write the last sentence for you. Water molecules in ice are arranged in a regular, orderly, crystalline pattern which permits only little movement. When ice melts, what happens? The water molecules move freely and there will be disorder in the structure. There will be disorder in the structure. And also when water evaporates, that means when it converts into gaseous state, there will be much disorder in vapor state. In order to explain this disorder, second law of thermodynamics introduced a new term, entropy. Okay, students? So this is all about limitations of first law of thermodynamics and spontaneous process and also non-spontaneous process and the examples under these processes. Okay, so next video I will explain you about the entropy and also changes in change of entropy in reversible and irreversible process. Okay, so kindly note down all these points in your notebook, students. Limitations of first law of thermodynamics, and next comes spontaneous and non-spontaneous process. Okay, so please write down carefully and also try to learn the points. Meet you in the next video with a new topic. Thank you, students. Take care. Bye-bye.